Welcome to the Barawan branch. This video outlines the construction of a replacement goods shed at the junction. But first, a few words on the existing shed. I scratch built it to dimensions that I derived from 3 photos of the shed that once stood at Terena. Those photos only showed the ends and the railside wall and roof. A cardboard mock-up using the derived dimensions was too imposing for the available site, so I reduced the length by 25%. The walls and roof are corrugated metal glued to a styrene shell. The prototype appeared to have roof skylights, so I included some on the model. I had no prototype photos of the roadside wall or interior, so I worked from photos of other sheds. While I was pleased with the shed overall, I wanted a more accurate interior. I also wanted to use scale-size corrugated metal sheets for the external cladding. Plans based on similar sheds at Yass and Gunning confirmed the dimensions I had scaled from the photos, so the new shed's footprint is the same as its predecessor. I began by making the roof trusses with stained scale lumber. I use jigs to make consistent copies of an item. Jigs repay the time it takes to make them. I used corrugated styrene sheet for the walls with the corrugated side as the interior face. I marked and made the wall openings using the scribe and snap procedure. For the ends, I first cut the roof profile using a truss sitting on the roadside wall. This accurately set the truss height. I then marked and made the door openings. The Terena shed differed from the plan by having a masonry section supporting the railside wall. I depicted this on the previous model with a piece of balsa. This time I used a styrene former, that I covered with brick embossed styrene. The masonry was first sprayed blue-gray. The mortar is a thin wash of dirty white flooded over the piece, allowed to almost dry and then rubbed off the brick faces with cotton swabs. Finally, charcoal dust was worked into the surface. The lumber was stained before making the frames. I used the plan's dimensions and frame arrangements as guides, but the model's window and door locations are different from the plan. The cross bracing on this wall is too wide and will be replaced. Narrower section cross bracing has been used on this wall. Note that the frames on the end walls are recessed on each side so that the side walls, that have the corner posts, can be fitted inside the ends when the model is assembled. The new shed fits perfectly within the existing footprint. The internal deck is made board by board with scale lumber. The deck surface was made by gluing lumber strips together. The ends were kept square with a ruler and set square fixed to the work surface. A bar was used to push each strip firmly against the deck. The bar was then placed on the newly glued pieces to hold them flat until the glue set. Joists were then glued to the underside of the deck. The ruler and set squares kept the joists square to the deck timbers. I used styrene strip to space them at about 18 scale inches center to center. The exact spacing between centers was calculated by dividing the deck length by the number of joists required. The spacing strip was cut to the exact distance between adjacent timbers. I then worked inwards from each end, regularly checking that everything was square. Bearers were then glued to the joists. Each bearer was clipped to a square bar to keep the lumber straight while the glue set. The office occupies a small area in the shed corner. It consists of two walls that are not full height. The walls are board-by-board construction and capped by a length of timber strip. I glued a piece of black card between the wall frames to depict a chalkboard. I made the stairs by first fabricating a pair of stringers from scale 1x8 lumber. This was done by fixing two lengths at 90 degrees to each other, before setting a piece of 1x6 at 45 degrees across them. Then, another piece of 1x6 was set parallel to it with a 2 scale inch gap between. This is where a step tread will be glued. The process was repeated to give 4 steps plus 6 scale inches above and below the outer steps. The excess 1x6 was removed and the stringers cut to length. Finally, the 2x8 treads were glued in the gaps on one stringer. Once set, the other stringer was glued to the treads. Blue-black brick paper was wrapped around short lengths of square styrene rod to depict the brick supports for the deck bearers. Briefly, the brick paper was cut to width and the correct length to wrap round the square rod. One end was glued to the midpoint of one side. Then, the paper was scored with the back of a knife before folding the paper around to the next side and glued, and so on until all 4 sides were covered. To keep the walls straight at the base, lengths of styrene rod were glued inside the shed perimeter. At the top, small braces were glued to the underside of each truss to help keep the wall straight and the correct distance apart. I made a jig to aid cutting the corrugated metal into sheets. I used contact adhesive to glue the sheets to the styrene walls and roof panels. I did one row at a time so I masked the remainder of the wall. By doing one row at a time, I was able to spray adhesive onto the top few millimeters of sheets that had already been laid, which improved the bond between those and the next row of overlapping sheets. I sprayed primer on the walls before spraying on several coats of light gray acrylic. The timber for the trims was painted before cutting and fitting them into the wall openings. I began with the top and bottom trims. I use a vernier caliper to accurately measure each piece. This ensures a good tight fit and no gaps at corner joins. Then I measured and fitted the side trims. I faded the paintwork by randomly brushing IPA onto individual corrugated sheets. Then a dry brush was rubbed over the sheets to remove some of the IPA softened paint. This partially removed some of the top coat and exposed the undercoat. The light gray acrylic has a blue base, so the change in tone between sheets is quite effective. Further weathering, in the form of dry brushing and powders, will be added later. The windows were fabricated board by board. 0.1 mm clear styrene was cut to fit snugly within the window space. I then glued scale timber framing in front of and behind the glazing. The doors were made board by board using the dimensions and board patterns detailed in the plan. The scale lumber was first stained, then sprayed with the trim color. This gave the doors a slightly weathered look. The roadside sliding door has elaborate paneling. The runner is fabricated from styrene strip and channel, and the rollers are discs punched from thin styrene sheet. The roller brackets are styrene strip. The assembly was painted rust, then silver acrylic was dry brushed along the running surfaces. Finally, charcoal powder was dusted over everything. Getting each corner joint square and plumb is key to building a sound structure. Here a machine block supports the roadside wall and one end while the glue sets. The clips provide additional support. After the four walls were glued together, the assembly was glued to the styrene base. Corner braces were added at the wall tops per the plan. Then the deck was glued in place on the footings. Finally, the office walls and the doors were added. Now's the time to add freight to the deck. With all the freight in place, the trusses were glued to the wall tops. A ridge beam was run through the trusses, as was another beam near the truss bases. The lower beam supports 3 cosmetic light fittings. I attached 2 LED units to timber supports strung across adjacent trusses. The LED wiring was run through painted styrene tube to keep it neat and out of sight. Purlins were fitted to the inside faces of the roof sections before adding the skylight framing and glazing. The roof sections were faded in the same way as the walls. Roof brown was dabbed on with a piece of sponge. A dry brush was then drawn downwards over the paint dabs. Various shades of rust-colored powder were worked into the drying paint. The ridge cap is 1 mm styrene rod glued into the gap between the roof sections and covered with cigarette paper, which also was used for the flashing around the skylights and the barges. Styrene channel was used for the gutters. It was glued to pre-painted fascia boards attached to the truss ends. To do this accurately, I clipped a thick piece of lumber to the fascia and set the channel on this while the glue dried. The downpipes are brass rod bent to shape. They are attached to the walls with etched brass astragals. The barge boards are pre-painted scale lumber. They are glued to the purlin ends. The vehicle guard under the roadside door is made of scale lumber. The gutters and downpipes were painted dark brown before setting the shed in place. The LED wiring was connected to feeders that passed through a hole in the deck inside the office. The final task was to touch up the ground cover and grass around the shed. I mounted a mini camera on a wagon to get this view of the interior. Note the various items of freight and the office in the far corner. The rail side can only be viewed with a camera, which is a shame as I think it's quite convincing. I am pleased with the completed model. It was a satisfying project that included some challenges. Thanks for watching.